Good morning, one and all. My name is Dr. Balajee Maram, Professor, School of CS and AA, SR University, Varangal, Telangana. Today, we will discuss about the concept grid and cloud computing. So here, both are almost similar. Actually, the base for cloud is grid only. Uh, when our mission capacity is not sufficient, definitely there is a need to increase the capacity of the laptop or desktop. But we can increase the capacity up to some point. But after the point, we can't we should replace entire laptop or desktop. So these are the limitations in our desktop or laptops. So, but when there is a big application, we need to run that application. Then how it is possible? In our single system, it is not possible to run that big application because so much of computing power is required and so much of means storage capacity is required. So how it is possible? So that is the reason the grid and grid computing came to technical world. Okay. So here, what is a grid computing? Grid computing can be defined as a network of computers working together to perform a task that would rather be difficult for a single machine, and all machines on that network work together the same protocol to act like a virtual supercomputer. The tasks that they work on may include analyzing huge data sets or simulating situations which require high computing power. Computers on the network contribute resources like processing power and storage capacity to the network. So this is grid computing. Grid computing, when different resources are available in our organization, first of all, we need to create a network of all network and which connects all the components in the organization. Suppose thousand systems are there in our organization. First of all, we need to create a network and we need to create a means grid. It acts as like a grid. So in the grid, you can connect every device, means scanner, printers, means photostat machine, everything means automatically the computing power will be increasing and the storage capacity will be increasing, and we can use the grid for big applications. You can run big applications in the grid, and you can store the means huge volume of data in the grid. Here a grid computing network mainly consists of three types of machines. First one is control node. This control node actually it controls each and every node in that particular grid. The grid contains two types of machines. One is node, second one is control node. Nodes are like data nodes, which contain some data and other resources, means some computing power and so on. And the second one is control node. The control node simply controls the node. It schedules different types of tasks in the grid. Second one is provider. The computer which contributes its resources in the network resource pool. We suppose already I told different resources in the grid. Suppose a printer is provider, scanner is the provider, and some laptop is the provider, some desktop is the provider. These are the providers. And third one, user, the computer that uses the networks on the network, resources on the network. Right, this is the picture of topology in the grid computing. So here you can find different types of machines. Some nodes have Kali Linux, Windows, Ubuntu, Debian, Linux Mint, Mac, and so on. Different platforms are there. So those are the ordinary nodes, and one control node is there. The control node connects each and every node, and it controls the processing of each and every node. This is the overall picture of the grid computing, and where to use grid computing. It is some of the common applications of grid computing: artificial intelligence, and computation, computational aerodynamics, computer vision, remote sensing applications, pattern recognition, and so on. We can find so many applications where the grid is able to run such big applications. Okay. Next one, advantages of grid. It is not centralized as there is no servers required except the control node, which is just used for controlling, not for processing. Is it okay? So here, grid is like a distributed computing. It is not like centralized. Means it is not like a client server. It is like distributed. Means each and everything will be done in that specific system only. There is no one system like a server. Okay, multiple heterogeneous machines are connected to grid. Means machines with different types of operating systems are connecting to server, and a task can be performed parallelly across various physical locations, and the users don't have to pay for it. Okay? Because each and every system belongs to same organization. That's why there is no need to pay anything for using different types of services are available in that particular grid. Next, these are the comparisons between the grid computing and cloud computing. So here, first point, user management. Grid computing, it is purely based on the decentralized, means distributed computing, decentralized management. Means every task is decentralized. Means there is no controlling system in the grid computing, but in cloud computing, it is strongly binds with the centralized management. It means one system takes the control and it controls all the systems centrally. Okay. Second one, dependency. Other computer picks up the work whenever the computer stops. Suppose the grid may contain 100 systems. Suppose two systems are failed automatically. The remaining nodes takes that load. Those two failed systems load. So that will be happened automatically. That is in grid computing. But whereas in cloud computing, totally depends on the network. Means there is means each and everything will be happened through internet only. When there is internet, everything will be going on smoothly. But when there is no internet, you cannot access even a single system in the cloud computing. Operation operates within corporate network. Within a corporate network means that is like it will be working in LAN, MAN, WAN only. But in cloud computing, it is also working in LAN, MAN, WAN as well as public internet. That is one additional advantage in cloud computing. That is also one of the limitation in cloud computing. Next, accessibility through grid middleware. Means there is a specialized hardware company that is middleware, that is grid, that is called grid middleware. So means those systems are accessible through grid middleware, whereas in cloud computing, means it is execution possible through standard web protocols. Next, domains, multiple domains. Here it is a single domain. Scalability in grid computing, scalability is very very limited, because you cannot increase the capacity, you cannot decrease the capacity dynamically, because that is the reason here scalability is very limited. Whereas in cloud computing, the scalability is very very high, because instantly you can increase the 100, you can include 100 nodes, you can remove 100 nodes or 50 nodes, whatever it may be. It is possible dynamically. It okay. Dynamically, you can increase the capacity, you can decrease the capacity. That is scalability and architecture. Means here it is a distributed computing architecture. In cloud computing, it is a client server architecture. And virtualization, data and computing resources are virtualized. But here in cloud computing, hardware and software platforms are virtualized. Computation, maximum computing But in cloud computing, it is on demand. Means based on the demand, means the competition will be increasing or decreasing. But in grid computing, it is uh, fixed. You cannot increase, you cannot decrease. The cloud infrastructure. The cloud infrastructure is a term used to describe the components needed for cloud computing, which includes hardware, abstracted resources, storage, and network resources. Think of cloud infrastructure as a tools needed to build cloud in order to host services, applications in the cloud. You need cloud infrastructure. Okay, cloud infrastructure means it is some set of components which provides services to the end users. Okay, and how does cloud infrastructure works? An abstraction technology process like virtualization is used to separate resources from physical hardware and pool them into cloud. Automation, software, and management tools allocate these resources and provision new environments so users can access what they need when they need. Here, what is included in CI, cloud infrastructure? The cloud infrastructure is made up of several components, each integrated with one another into a single architecture supporting business operations. A typical solution may be composed of hardware, virtualization, storage, and networking components. As a team, cloud infrastructure can be used to describe a complete cloud computing system once all the pieces are put together as well as the individual technologies themselves. Here, these are the components. First one is management software. Second one, deployment software. Third one, hypervisor. Next, network, server, storage. This is the first one is hardware. Means a cloud network is made up of variety of physical hardware that can be located at multiple geographic locations. Means when we talk about hardware, it is like in a city, you can find different types of hardware in different types of locations because it is all those components are connected through LAN, MAN, WAN. Okay, so that is the reason you can find a single location, means single organization or multiple organization in a city. The hardware includes networking equipment like switches, routers, firewalls, load balancers, storage arrays, backup devices, and servers. Virtualization connects the servers together, dividing abstracting resources to make them accessible to the user. Virtualization means reality is different. It is combination of hardware components, but virtualization creates one layer. That layer hides the different types of hardware components. Virtualization is a technology that separates IT services and functions from the hardware. Means it divides IT services and functions from the hardware. Software called a hypervisor sits on top of physical hardware and abstracts the machine's resources such as memory, computing power, and storage. Once these virtual resources are allocated into centralized pool, they are considered cloud. With the clouds, you get the benefits of self-service access, automated infrastructure, scaling, dynamic resource pools. Okay. And what about storage? Within a single data center, data may be stored across many disks in a single storage array. Storage management ensures that is correctly being backed up and that outdated backups are removed regularly and that data is indexed for retrieval in case of any storage component fails. Virtualization abstracts storage space from hardware system so that it can be accessed by users as cloud storage. When storage is turned into a cloud resources, you can add or remove drives, repurpose hardware, and respond to change without manually provisioning separate storage servers for every new initiative. Network. The network is composed of physical wires, switches, routers, and other equipment. Virtual networks are created on top of these physical resources. A typical cloud network configuration is composed of multiple subnetworks, each with varying levels of visibility. The cloud permits the creation of virtual local area networks, VLANs, and assigns static and dynamic addresses as needed for all network resources. The cloud resources are delivered to users over a network, such as the internet or intranet, so you can access cloud services or apps remotely on demand. What about cloud infrastructure versus cloud architecture? So here, cloud architecture is like virtual, that is like blueprint, but cloud infrastructure is the reality. Means here, the cloud infrastructure is a collection of various components which belongs to the same owner or same organization, and those are connected through LAN, MAN, WAN. Okay, but whereas cloud architecture means it is like idea how to how many components are there and how to connect those components and how to create such a cloud network and so on. So this is like in a OOPS concept also. Object is the reality, class is the virtual. Means class is the blueprint only, but object is the reality. Means object is the tangible component. Class is not a tangible component. So infrastructure in three cloud architectures. Means you can arrange the cloud infrastructure according to three different cloud architectures. First one, the private cloud architecture model. The cloud architecture is accessed by just a single organization. Private cloud architecture may be developed and maintained by on-site IT staff, or it may be delivered by external service provider. Suppose when there is a small organization or big organization, they want to create their own means cloud that is called a private cloud, because the entire thing is under the control of a single organization, and that single organization only using different types of services from that particular cloud, and it is under the control of themselves only. Okay, or sometimes it may be given to some external service provider. And the second one, the cloud architecture is that is a public cloud. It is consists of third-party cloud service providers who offers cloud resources to paying customers over internet. Means a private cloud means that is purely related to some organization only. But as a person, when as a technical person, when we want to use the cloud services, definitely you can use the cloud services from the public cloud. So public cloud provides use a multi-tenant environment model to leverage economies of scale and lower the cost of computing power and the data storage for their customers. The multi-tenant environment is effective at lowering the overall cost of computing resources, but it may also create privacy concerns for companies that deal with sensitive data. Just a hybrid cloud, it is like a combination of public cloud and a private cloud. Sometimes they want to store their data in private cloud, but they want to use the different types of services which are available in public cloud. So in such scenario, they can create a hybrid cloud. That hybrid cloud is a combination of means some services from private cloud and some services from public cloud. Okay, means most probably the data is available in the private cloud, and different types of services are from the public cloud only. So that is the reason the hybrid cloud also plays a vital role in today's market. And three cloud infrastructure delivery models means earlier three are the cloud architectures. These three models are delivery models. First one is IaaS. IaaS, infrastructure as a service model. A cloud service provider delivers networking, okay, data storage, servers, virtualization capabilities. The customer gains access to as much data storage and computing power as they need. but will be required to provide their own software platform to run on it. Okay, infrastructure. It provides own infrastructure. This includes operating system, runtime, middleware data, and applications. Second one is platform as a service. A cloud service provider delivers the full cloud infrastructure, means networks, servers, data virtualization, along with a software platform that includes operating systems, middleware, and runtime. The PaaS model is meant to provide customers with the capability to develop, test, deploy, and operate their own applications in the cloud without the typical expense and complexity of building on-site IT infrastructure. Third one, SaaS, software as a service. A service provider delivers an application through web-based portal. This removes the need for customer to store any information about the application on their local disk. All of the data storage is located on the servers of service provider. Yes, SaaS companies are responsible for every aspect of the technology stack, from maintaining the cloud infrastructure that supports the application to the application itself. SaaS. SaaS utilizes the internet to deliver applications which are managed by a third party vendor to its users. A majority of SaaS applications run directly through your web browser, which means they do not require any downloads or installations on the client side. That is the main advantage from the SaaS, software as a service. Just there is a need of internet. That's it. With SaaS, vendors manage all potential technical issues such as data, middleware, servers, and storage, resulting in streamlined maintenance and support for the business. So here, what are the characteristics? Yeah, managed from a central location, hosted on a remote server, accessible over the internet. Users are not responsible for hardware or software updates. These are the four important points. It is from central location only, hosted on some remote server. We don't know where is that server, and accessible through internet. And user is not responsible for any software updates or hardware updates. When to use SaaS? SaaS may be the most beneficial option in several situations. Startups are small companies that need to launch e-commerce quickly and don't have time for server issues or software. Most of it is very useful for startups or small companies when they are not in a position to invest much money on the business. In such scenario, definitely they can check their business by taking the help from the cloud SaaS through SaaS. Okay, short-term projects that require quick and easy, affordable collaboration. Suppose when there is a small project but collaboration is required, and the team members are scattered throughout the world. In such scenario, definitely SaaS plays a vital role. And applications that need both web and mobile access. In such scenario, SaaS is very, very useful. SaaS limitations, interoperability. Okay, integration with existing apps and services can be a major concern. That is very difficult task. Integration with existing apps and services. Next, vendor luck. Vendor may take it easy to join a service and difficult to get out of it. Because suppose when we are using services from one company, we cannot switch to other company easily because everything is binds with the existing vendor. Again, we need to shift each and everything to the new vendor means it is a little bit very difficult task. Next, lack of integration support. Many organizations require deep integrations with on-premise apps, data, and services. Next, data security. Data security plays a vital role. In any case, here also the same thing. We can't find 100% data security under SaaS. Next, customization. SaaS apps offer minimal customization capabilities. As examples of a SaaS, who are providing SaaS? First one, Google Workspace. Formerly it is a G Suite, Dropbox, Salesforce, Cisco WebEx, SAP Concur, go to meeting. Next one is PaaS, Platform as a Service. So here, PaaS delivers a framework for developers that they can build upon and use to create customized applications. All servers, storage, networking can be managed by the enterprise or third-party provider, while developers can maintain management of the applications. This platform is delivered via web, giving developers the freedom to concentrate on building the software without having to worry about operating systems, software updates, storage, or infrastructure. So here, these are the characteristics. PaaS has many characteristics that define it as a cloud service. First one, building on virtualization technology. So the resources can easily be scaled up and down as the business changes. Provides a variety of services to assist with the development, testing, and deployment of apps, and accessible to numerous users via the same development application. Integrates web services and databases. And what are the advantages? No matter the size of your company, using PaaS offers numerous advantages. These are like it is like simple, cost-effective development and deployment of apps. Second one is scalable. Means easily you can scale up and you can scale down. Third one is high available. Definitely, when we talk about cloud, automatically high availability should be there. Then here also same high availability possibility is there, and developers can customize apps without the headache of maintaining software. Means here, means they can customize apps without maintaining hardware software. Significant reduction in the amount of coding needed. Miscoding part is very less. Next one, automation of business policy. Next, easily migration to the hybrid model. Okay, easy migration. Next one, when to use pass. Sometimes, even in several, for example, PaaS can streamline workflows when multiple developers are working on the same development project. If other vendors must be included, PaaS can provide great speed and flexibility to the entire process. PaaS is particularly beneficial if you need to create customized apps. And this cloud service also can greatly reduce costs, and it can simplify some challenges that come up if you are rapidly developing or deployment an app. Next, what are the limitations? First of all, data security, like it says, here also the same problem. We can't find 100% security in PaaS also. It is very difficult. Second one, integrations. Is particularly when not every component of legacy IT system is built for the cloud. Integration with existing services infrastructure may be challenging. Means already some existing components are there. Through past, we can't integrate all those components successfully. Next third point, vendor lock. Here, vendor lock is a limitation in many cases. Here also same. When we use the services from one service provider, automatically our data and applications are binds with that particular service only. But when we want to move to some other cloud provider, it is a little bit difficult to move here and there. So that is nothing but vendor logging. Next, customization of legacy systems. PaaS may not be a plug and play solution for existing legacy apps and services. Runtime issue. Specific framework versions may not be available or perform optimally with the PaaS service. And these are the examples of PaaS: AWS Elastic Beanstalk, Windows Azure, Heroku, Force.com, Google App Engine, and OpenShift. So here you can check it. These are the different means platforms who provides the service PaaS. Next, Google App Engine supports distributed web applications using Java, Python, PHP, and Go. Red Hat OpenShift is a PaaS offering for creating open source applications using a wide variety of languages, databases, and components. The Heroku PaaS offers unique style container computing instances that run process in isolated environment. Next, Microsoft Azure supports application development in .NET, Node.js, PHP, Python, Java, Ruby, and so on. And AWS Elastic Beanstalk allows the users to create, deploy, scale web applications and services developed with Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker on common servers such as Apache and IAS and so on. And popular POP providers and services that are provided by them. First one, Google App Engine, App Identity URL fetch, cloud storage, client library, log service. Next is Salesforce.com, faster implementation, rapid scalability, CRM services, Sales Cloud, mobile connectivity, and charter. Next, Windows Azure, computer security, IoT, and data storage. App Fog, JustCloud.com, SkyDrive, Google Docs. Next, OpenShift, Red Hat, Microsoft Azure, Cloud Foundry from VMware, data, messaging, and other services. Next one, IaaS infrastructure. So here, infrastructure as a service. Cloud infrastructure known as infrastructure as a service are made of highly scalable and automated compute resources. IaaS is fully self-service for accessing and monitoring computers, networking, storage, and other services. It allows businesses to purchase resources on demand and as needed instead of having to buy hardware outright. IaaS provides the same technologies and capabilities as traditional data center without having to physically maintain or manage all of it. IaaS clients can still access their servers and storage directly, but it is all outsourced through a virtual data center in the cloud. IaaS provider provides the following services: compute. Computing as a service includes virtual center, central processing units, and virtual main memory for VMS that is provided to the end users. Storage. IaaS provider provides backend storage for storing files. Network as a service provides networking components such as routers, switches, and bridges for the PSM. And the load balancer say provides load balancing capability at the infrastructure layer. And what are the characteristics? Resources are available as a service and the cost varies depending on consumption. Services are highly scalable, multiple users on a single piece of hardware. Organization retain complete control of the infrastructure, dynamic and flexible. These resources are available as a service and cost varies depends on consumption only. And these are highly scalable services. You can increase the number of services and you can decrease the number of services in the cloud. Multiple users on a single piece of hardware. Organization retain complete control of the infrastructure. Everything is dynamic and flexible. What are the advantages from IaaS? The most flexible cloud infrastructure model and easy to automate deployment of storage, networking, servers, and processing power. Hardware purchases can be based on consumption. Clients retain complete control of their infrastructure. Resources can be purchased as needed. Highly scalable. Disadvantages. Security is a major concern. In any case, here also same problem. We can't expect 100% security. And second one, maintenance and upgrade. The IaaS service provider maintain the software, but they do not upgrade the software for some organizations. And interoperability issues. It is difficult to migrate virtual machine from one IaaS provider to the other, so the customer might face problem related to vendor locking. But when to use IaaS? Here, startup and small companies. So when it is a startup or when it is a small company, they need to check their capacity. They need to check their skill and other things, business things. So that is the reason initially they can start their business with the help of IaaS. Second one, larger companies may prefer to retain complete control over their applications and infrastructure, but they don't want to purchase only what they actually consume or need. Companies experiencing rapid growth, like scalability of IaaS, and they can change or change out specific hardware and software easily whenever required. And what are the limitations and concerns? Security, as usual, security is a major limitation in any service. Second one, legacy systems operating in the cloud. Means already some existing systems are there, but we cannot combine these two technologies. And third one, internal resources and training. And here, human resources. They don't know how to use these IaaS services. That's the reason again there is a need to create some training and awareness creation sessions. Multi-tenant security. Since the hardware resources are dynamically allocated across users as made available, the vendor is required to ensure that other customers cannot access data deposited to store assets by previous customers. These are the examples of a IaaS. First one, Google Miss Compute Engine, DigitalOcean, Linode, Rackspace, AWS, Cisco, Meta Cloud, and Microsoft Azure. Okay, these are the top IaaS providers. Amazon Web Services, Elastic, EC2, MapReduce, Route 3, 53, Virtual Private Cloud, etc. And NetMagic Solutions, IaaS, it provides IaaS, Rackspace, Cloud Servers, Cloud Files, Cloud Sites, Reliance Communication, Reliance Internet Data Center, CP Technologies, CPIS, Tata Communications, Insta Compute. These are the some miscomparison between IaaS, PaaS, and SaaS. First of all, on-premises when different components are there, applications, data, runtime, middleware, OS, virtualization, servers, storage, and networking. But when we talk about infrastructure as a service, we need to manage applications, data, runtime, middleware, and OS only. Remaining thing is under the control of third-party vendor, virtualization, servers, storage, and network. But when we talk about the platform as a service, means we can manage applications and data only. Then remaining runtime, middleware, OS, virtualization, servers, storage, and networking is under the control of third party only. But when we talk about the software as a service, everything is under the control of third party only. We should not maintain anything from our side. Okay, these are the comparisons between these three deployment models. Okay. Thank you very much. Till today, till now, we have discussed about what is grid and how it is comparing with cloud computing, and what about cloud architecture and cloud infrastructure, and deployment models, IS, SaaS, PaaS, IS, and how those are comparing each other. These things are covered in this slide. Thank you very much.